Now, a really useful thing about pressure changes in fluids is called Pascal's principle. So basically, the Pascal's principle says a change in pressure at any point in a confined fluid is transmitted everywhere throughout the fluid. This is useful in making hydraulic lift. So for example, in order to lift this huge heavy truck above the surface in order to get down there and fix things with that, you would need a lot of force. But using our Pascal's principle, what they do is they exert a small force on a smaller container of piston here of a very tiny cross-sectional area A1. This force is transmitted over to the bigger container that is holding this pressure up, and it acts over a larger distance and is able to lift this truck up. So at point 1, which is here, the pressure at point 1 is equals to the change in pressure at point 2. So pressure is given by F1 over A1, which is equals to F2 over A2. So F2, which is a larger force, can actually be gained by a smaller force, which is F1. So now let's look at an example. Assume that a force of 500 newtons, which is very little, about 110 pounds, is applied to a smaller piston as in the previous figure. For each case, compute the force on the larger piston if the ratio of the piston areas are 1, 10, and 100. So applying using Pascal's principle, what we need to do is quickly go back and look at this slide, right? So they're saying that the areas A1 and A2 are related by the figures, and F1 and F2. So we're going to be using this formula to calculate F2, which is going to be A2 over A1 and F1. So I've just put that into a table here for you, which means A1 over A2, when it is 1, F2 is going to be 500 newtons. The ratio of the areas is 500 newtons. We put in 500 newtons and you get out 500 newtons. Now, if you were to change the ratio of the area A2 to A1, make it 10 times that of A1, then in fact you will get 10 times the force on the outside. Now, if you were to make the area A2 be 100 times that of A1, then you would get 50,000 newtons of force. So the idea is the work done in pressing the smaller piston equals the work done by the larger piston. Using an hydraulic lift reduces the amount of force needed to lift a load, but the work done is exactly the same. So the work done by 1, which is given by F1 D1, is the same as F2 D2. So now let's look at this example. For the case A2 over A1, if it's equals to 10, it was found that F2 over F1 is 10. If the larger piston needs to raise by 1 meter, how far must the smaller piston be depressed? So from the results in the previous slide, D1 will be equals to F2 over F1 D2, which is going to be equals to 10 meters. So you will have to move the smaller piston 10 meters if the larger piston needs to move up by 1 meter.